Robert Lamar.
Diyos ko, gusto mo doon. Hindi naman.
Iwanan ka namin doon.
Ayoko na. Hindi ko pag pauwi mo, hindi pwede ka nandun. May mga dadaan ng
Kami new market. Ay, kasi naman siya ba?
Ganun din. Tapos isipin mo marami sa
Isa ka po.
Tapos mo yung registration kasi. Akala ko lang din. Kasi na kasi nung kahapon.
We are now arriving at Morningside. Please mind the gap between the train and the platform at the station.
Simulan nyo na yung registration.
Yung pandang din. Sinimulan ko na yung registration. Ay, saan?
Medyo ma-tuloy pa yun eh.
Madam, saan ko nakuha yung sa mga hasay-hasay ko? Ba't hindi makikita?
Asay? Siya lang ang meron.
Ikaw lang nag-ano.
Nasa Teams. Ikaw. Sina-search ko lang sa Teams. Tsaka may mga Teams siya eh.
Paano nga ba't alamin mo? Kasi yun ang alam ko.
Consumer size, list the 10 rice. Yun yung color red na pinakita kanina. Tapos ito, take 5 of the above. Uli ka lang doon sa 5. Tapos paano ko ito gagawin sa practice. Scope of nursing practice sa NC. Ito yung nasa NCNZ. Nasa about us. Tapos ito, yun may mga hint. Go to.
Yan nga. Saan yan?
Eh, sa HPCA after.
Sa links mo rin hanapin o sa Google na lang?
Pwede sa Teams, pwede sa Google. Pero yung ginamit ko sa Teams.
Saan doon?
Ano, di ba ito?
Yung sa hazard, sa hazard.
Hazard. Ito, health and safety workshop. Balik tayo sa lecture.
The next station is Kingsland. Mount Eden Station is temporarily closed for redevelopment. A bus service, number 64, will run every 15 minutes between Mount Eden Station, Kingsland Station, and Grafton Station. Visit at.gov.nz/Mount Eden Station for details.
Okay, nung ako sa Google.
Hindi na ando.
Ha? Bakit iba sa'yo?
Wait, parehas lang yan. Teka, buksan ko ha.
Bakit yung chika lang?
Health and safety.
We are now arriving at Kingsland.
Ayun ako nagkakaroon. Hindi ko nga alam. I-Google ko na nga lang sa sobrang distress. Hindi ko natapos. Kaya nga.
HDC ko.
Yan. Ito na sa taas.
Try natin. Ay, triage tool to eh.
Ay, tinuwa ko na lang sa Google.
Bakit ang dami-dami sa kanya? I-browse mo. Kasi kung sa ganito, hindi naglo-load.
Oo, hindi nag-load.
Akala mo ay yun lang yung laman, pero hindi talaga. So, kunin lang yun yung server.
Paborito ka sa server.
Hindi ko pinapaglaw. Hindi nga ako, hindi ko nga makausap eh.
Accepted ka lagi. Kaya yung mga, ano yung estudyante may exempted, may mga bullies.
Sorry. Saan ko nga natin tayo? Nandito lang yan. Basta nandito lang sa send mo sa akin.
Accelerated ka pala. Kaya nga, ba't alam mo yan? Ako di ko alam yan.
The next station is
Feeling ko next
Grafton.
Ay, ito!
Your 80 hot card or ticket may be checked at any time.
Tapos nandito yung hazards. Sa padlo.
Yan, nakikita ko yan. Hindi mo wala dyan.
Yan, sa kayo. Chemicals. Ito lang yun. Responsibilities.
Ano mo? Okay. Sige.
Tapos ginawa ko na lang, inano ko na lang, i-replace ko na lang. I-replace ko na lang. Yan.
Wala akong nire-replace. Copy-paste ko.
Kasi ano, pagka-copy paste mo, di ba nakalagay na doon Meron ba?
Wala yun. Nagkamali ako dun sa drops. Dapat 5 drops pala.
5.
Nandun lang sa ano, di ba?
Andun lang din sa slice.
Kasi lang naman, di ba, yung may, ano, may QR scan. Ano dahil, hindi ay ano, ako, gusto ko talaga ng kanin. Dapat sa isang week, pwede kumain ng kanin. Tapos kasi, late na tayo. Late na kita, uwi na ako. Walang bus namin. Hanggang sa bus. Nakailang bus na yung ibang bus. Kami wala ako yung bus namin. Paano na lang kami. Kasunod sa kaibigan. Para kami bus ang sis yung dalawa, napakalamig pa. Tapos na, ubos na lahat ng kanta.
Ubus na ang ano?
Kanta. Kinanta ko na lahat ng OPM, wala pa yung bus.
Makapag-concert. Tapos
So, concert na ako dun, wala na. Sa Friday na lang tayo dapat na.
Ako nga inasa Westfield.
Ayaw nga pala. Sige, mag-watch after na.
After ng
Baba ka sa Grito Mart. Baba ka sa Grito Mart.
Oo.
Diba?
Instead na papuntang Papakuras.
Hindi ko naman kasi kayo may meet. Ano, Wesley kayo. Magbabas kayo papuntang Grito Mart.
Doon
So,
na.
tapos Grito Mart doon na kasi station. Tapos
Diretso
ka na. Kapag alam mo, wala ng train.
Hello? Hindi ano. Hanggang 11 naman siya.
We are now arriving at Grafton. Exit here.
Had no intent, so just grabbed this library.
We are now arriving at Kingsland.
Alrighty, done. So I might do a little bit of an explanation for this. Okay. I don't have internet at the moment though. So yeah, when I get into the office, I'll do a bit of an explanation. Okay, so I said I'd give a quick explanation of this. So, how did we know to keep track of the visible pancakes and how to make a tree? Why did we make a tree from that? So, I guess it's the pancakes that aren't visible, which we can't really compare to each other, which is what creates a lot of different combinations of pancake orders that could generate the visibility orders that we need to generate. But yeah, if we don't have that insight yet, then let's just look at all pancakes, all possible pancakes that are coming along, and see what information we can get out of that. So let's just say we have a pancake, and then we've got the visibility count increases. So we've got a smaller pancake, and then we've got a smaller pancake. So we can see the numbers increasing. So it's gone from 1 to 2 to 3. And then let's say we have a bigger pancake. So now the number's gone, let's just say back to 2. So it's just this one and this one that are visible now. What does that tell us? It tells us that we know this pancake's smaller than this, we know this one's smaller than that, and now we know that this one is bigger than these two, right? What we also know is any pancakes that come after here, they'll never be able to be compared to this. If a pancake is smaller than this pancake, then we won't know, was it bigger than this or not? If it's bigger than this pancake, so if we have a bigger one, then we know it's bigger than these two. So this bigger pancake is kind of shielding these two. So it's kind of creating a bubble. So why not, instead of drawing it like that, why don't we draw it like that? So we're kind of creating our own little bubble. And yeah. So each time we get a larger pancake, instead of drawing it there, let's just draw it around the ones. And then we could even have one, a really big one now that comes around all of them. Or it could just come around these two. And so that kind of looks like a tree, right? So whenever some pancakes go into a bubble, then we can connect them up, right? Because nothing else can touch them again. So that's why in my code, when I had a larger pancake come along, I drained all of the lost pancakes and connected them up like this. At this point, I wouldn't connect this one because I don't know yet if a larger pancake is going to come along. So I don't know, at this point, I don't know if I have this edge here or if I have an edge coming in to like a larger one that's surrounding it. But yeah, as pancakes get lost behind larger pancakes, I'm able to basically draw this graph. Now let's just say this is our final pancake. This was our last pancake here. Then now we would have all our arrows done by then. So let's just say, so now we have like this tree structure of pancakes, which is quite cool. So every pancake has, the earth pancake has children child pancakes, which is the indices of all the pancakes that are directly smaller than it. So yeah, in this example, do I have anything with multiple children? I don't think so. So we don't have any with multiple children. I'll just clear this. So if I have a really big pancake in the middle, so a large pancake in the middle separating some small pancakes to my left and the right. Those pancakes to the left and right can't really interact with each other because of this large pancake in the way. So in this case, you can see this large pancake has two children, right? So yeah, it's a tree. So it's basically just a tree, right? With the largest pancake at the top, and then based on how many children we have. And so as we know, we can't compare pancakes at a certain level. Like we don't know which is biggest out of these three, which means these subtrees could be in any order. So basically our job, now that we've got this tree, is to figure out how many possible trees are there. Well, firstly, if we know the answer for here, this subtree, and we know the answer for this subtree, and we know the answer for this subtree, then we just multiply those together. And why is that? Well, it's kind of similar to the reason that, n factorial is usually how many different ways. Oh, it's not similar to that. It's similar to how many numbers are there in a grid, right? So let's say you have a grid, and at the top you have like, I don't know, X, and on this is like Y. Then each cell will give you like well, let's just call it IJ. So each cell is like an IJ combination. So you just multiply the number of rows and the multiple number of columns. So if it was just two, we just multiply these together, and then once we have this many, then we just multiply that with this. And so basically, we just times all of these together. So it should be kind of straightforward. But then we also need to take into account that the total number of sizes, so this is a permutation, like of a whole lot of different sizes, size pancakes. So how do we know which pancakes go to which subtree? So say I have a pancake of size 5, that could have gone to any of these, right? So the way I did that was saying, if I know the size of each subtree and I know the total size, then the number of ways of assigning this many sized pancakes to this subtree is equal to, I think it's the binomial coefficient. So like, it's the number of ways of choosing this many from this many. And then when I get to this one, like assuming that this is already assigned, because it doesn't matter which order I assign them. So let's say I've already assigned that sum to that. Now the total remaining is just equal to this many, right? The sum of these two. So then I'd multiply by this many chosen from this many. And so I just keep applying the binomial, like n choose k formula, which is just equal to, that's equal to like, let's just say 10 times 9 times 8 or whatever. That's basically what this code is using. But it's using, because of the modular limit that they put on, you need to do modular arithmetic. So it's calculating like the inverse factorial and things like that to work it out. So yeah, just look up binomial. But yeah, I think that's pretty much it. So we just depth first search, and we just need to keep track of how many ways are there of calculating each subtree, plus what is the size of each subtree. And that's why our depth first search returned two values. Yeah, so we have the total size. We need to include our node in the total size and the answer. Yeah, what else should I explain? So yeah, here I mean, this is impossible, so Sarah, here I'm just adding the smaller cake on to the end. And here is like a larger cake, which is covering some smaller cakes. So this is how many got lost. And here I'm using viz.train. I actually should have used splits at, I think it is. Because then it just gives you, it splits the array, which is nice. Anyway, train's interesting. It basically just gives you an iterator over a range, and all those items get removed. Yeah, so, and then yeah, at the end I have to make sure if there's any pancakes that are still visible, I need to do the same thing and add them into the tree, and then do a depth first search. And this is where I'm trying to find the position of the largest pancake, because that's where I want to start the depth first search. So it's just the rightmost position where the count is equal to 1, which means, if we can only see one pancake, we know that there's a massive pancake on the top. So every time the visibility count goes to 1, that means there's a really big pancake on the top covering everything. And the last time that happens, that means that's the largest pancake. Yeah. Anyway, I'm going to get started on some work. First into the office this morning. So, yeah. Good luck everyone for round 2. We'll see if I do it. It's in the middle of the night in New Zealand, so it's not really ideal for me, but maybe. Anyway, catch you later. Thanks for watching, and feel free to subscribe if you like. Alrighty.